Hello! Today's video, finding derivatives of inverse functions. So sometimes we'll see it's quite straightforward, sometimes it's not, and we'll see what we can do in those cases. Let's remember an inverse function, we are switching the position of x and y, or graphically it is the function reflected on the line y equals x. Okay, let's get started. Okay, so if we get asked to differentiate the inverse function, so this one, for example, y equals x to the power of 3 plus 1, then how would we go about that? Well, first of all, we want to find the inverse function. So, of course, I get that by switching the position of x and y. Now, that is the inverse function, but that's going to be a little bit hard for us to differentiate because we want to find dy dx, so we want to make y the subject. So I can subtract 1 from both sides, do the cubed root. Now I might want to write that as x minus 1 to the power of 1/3, and now I can find dy dx. So of course this will be a chain rule, 1/3 drops down, x minus 1, the derivative of that is 1, so that's not going to change that. 1/3 minus 1 is negative 2/3. So right now I have the derivative, but I just want to write it as a root, so 3 cubed root of x minus 1, and that's squared. Okay, so that is the derivative of our inverse function. Now that's all well and good, but today what we want to look at is, what if it's a little bit harder for us to find an inverse function? We have a method that we can use to still allow us to differentiate. So let's have a look at one of those examples. So this example, differentiate the inverse function of y equals bracket x plus 1 bracket times bracket x minus 2 cubed. Find the inverse function. Well, we'll do it the same way, which is switch the position of our x and y. So I would get this. Okay, so that's my inverse function. The problem is I have x in terms of y. And on the right-hand side this time, that is way harder for me to try and make y the subject like I did in the previous example. So we're going to use a result to help us to do this. Now you really want to remember this one. So dy dx is the same as 1 over dx dy. Or it could be vice versa. So dx dy is 1 over dy dx. Okay, so the reason why that's going to be helpful in this example, hopefully you can see that I have x in terms of y for my inverse, so I can easily find dx dy just by using, well, this is a product here, so I can use the product rule. So if u is y plus 1, u dash is 1, v is y minus 2 cubed, v dash is 3. This is a chain rule, so just be careful, but the derivative of y minus 2 is 1. So it's y minus 2 to the power of 2. And then it's u times v dash and v times u dash. So this time I am finding, just remember here, I'm finding dx dy. So it will be y minus 2 cubed plus 3y plus 1 y minus 2 squared. And I can make that a little bit more presentable by taking out the y minus 2 squared as a common factor. Then I'll have a y minus 2 plus 3y plus 1, and group your like terms, 4y plus 1. Okay, so now I have dx dy. So dy dx, using our result on the right there, is the reciprocal of that, 1 over y minus 2 squared 4y plus 1. Okay, now if I want to find the gradient at any point, have a look at our point here, that's the value of x and y. Now I have my dy dx in terms of y, so I will be subbing in that y value of 3. So dy dx when y is 3 is 1 over 3 minus 2 is 1 squared, and 4 times 3 plus 1, so it is 1 over 13. So the gradient of the inverse function is 1 over 13 at the point 4,3. One more example on how we can find the derivative of inverse functions. So this one is y equals cos 2x over x. So if we start by finding the inverse, remember we want to switch the position of x and y. So x equals cosine 2y over y. Now that is my inverse, but again we've got the same problem as before. So remember our result. So I can find dx dy if I find the derivative of x in terms of y. This will be a quotient rule, so u will be, u is always the top, so cosine 2y, v is y, u dash is, cosine differentiates to negative sign, so it'll be negative 2 sine 2y. It's a chain rule, don't forget. V dash is 1, and my dx dy will be u dash times v. Remember, for the quotient rule, the order is important, isn't it? So let's make sure we get it right. So it'll be negative 2y sine 2y. And then it'll be minus v dash times u. So that's just 1 times cosine 2y all over, and it's going to be over v squared, so y squared. Now that's dx dy, but I want dy dx. So all I need to do there is a reciprocal. Now I can take out a factor of negative 1 on the bottom there, so I could just make it negative, negative y squared over be 2y sine 2y plus cosine 2y. Okay, so if I want to find the gradient of a tangent to the inverse function, now that's at this point here. So again, let's have a look. Well, I have dy dx in terms of y, so the point I'm going to sub in there is pi on 4. So let's find dy dx when y is pi on 4. So that'll be pi on 4 squared over 2 pi on 4, and sine 2 pi on 4 is sine pi on 2. And then plus cosine, same thing, be pi on 2, because that's 2 lots of pi on 4, which is pi squared over 16 over sine pi on 2 is 1, so this becomes pi on 2, and cosine pi on 2 is 0. So I end up with pi squared on 16 divided by pi on 2, which gives, oh, I forgot the negative here, didn't I? Sorry, negative, negative. So it is negative, and the pi's cancel, and 2 goes into 16 8 times, so it's negative pi on 8. And that is our final example. And there we go, how to find a derivative of an inverse function. Particularly when we find it more difficult to make y the subject, we have a method that we can use to help us do it. Alright, so hopefully you found it useful. Don't forget to smash the subscribe button, and I will see you in the next video.